All right. Hello and welcome to AWS Made Easy Ask Us Anything, episode number 41. I'm Stephen Barr. We're joined by our co-host, Rahul Subramaniam. Rahul, how
Hey
are you?
everyone, doing very well. Steven, by the way, I think your audio is suddenly something happened to it. For a second.
Is it
It's-
less or is it
It suddenly goes very deep with like a huge bass.
let's see if
Anyway,
I can. Well,
this is our
okay,
41st episode and first one after
what happened is I
spring break.
broke my little mic stand. So I'm on my backup system. The little mount sheared off, so I'm looking for a new. And somehow, as I was taking apart the microphone, I sheared off the buttons from the PCB. I didn't realize when I was unscrewing it that the buttons were fixed, but the housing was static. The housing moved, but the buttons didn't. And so I sheared the buttons off the PCB. We're going to have to figure out something.
Oh, man.
So we're on the road wireless this week. Next week, it should be better.
Sounds good. Anyway, it looks like this is our first episode after spring break. How was your weekend?
It was in Seattle here. It was the first real taste of spring, which is, and then it's 17 degrees Celsius, or like low 60s, mid 60s. But we enjoyed every last bit of the sunshine and just had a blast.
Yeah, we just went from 24 degrees centigrade to like 30 degrees centigrade.
The 30, that's in the 80s?
Yeah, well in the 80s.
We might be lucky to get there in the peak of summer. Although last year we got well past that.
Yeah, last year it got pretty hot in a few days.
I was talking to Darko over the weekend, and he was saying it was just blistering hot last year, and everyone had to. I remember I moved down to the kitchen, put my laptop on the kitchen table because I couldn't. It was so hot.
I can quite imagine. But it looks like your kids and everyone else got into the spring spirit.
They did. They did the lovely
cupcakes.
I put that on my LinkedIn. They made some really good cupcakes. They set up this lovely background, and my wife too. She set up this really nice background together. And check out these special effects. Let's see. It's gonna work. Oh, there we go.
That would have been a fun project for the kids.
So it was really, really fun. And then and then the kids had some friends over, and so you can see my my 4x4 Rubik's Cube is solved in the background. So they were doing that this weekend. So I need to learn the algorithms of how to do that.
Yeah, I tried a bit. I managed the 3x3. 4x4 is a little too much for me right now. The kids do it quite frequently.
Yeah.
Awesome. Okay, so we have a pretty packed show today with a lot of stuff to cover.
Where should we start?
Why don't we start with the new lower cost CodeBuild GPU offering?
Let's do that. Let me get my window. Oh, let's cue the transition, and we will talk about CodeBuild.
Okay.
All right, AWS CodeBuild now supports a small GPU machine type. So for background, CodeBuild is the relatively, very new IDE that was,
Actually, it's more than IDE. It basically allows you to build all of your, it's almost like a CI/CD backend where it allows you to build all of your code and deploy it.
Yeah, you're right. But having a GPU-based workload, that's really, really neat because GPUs are what's kept people local, and they're really difficult to set up, to get all the drivers right, to configure, especially when you have to deal with like the NVIDIA compiler or whatever. So having it built in, you can have your CI/CD with a GPU with a GPU enabled. Is that the use case this is enabling?
Yeah, I mean, there are a lot of use cases, especially now with AI related, workloads or analytics related workloads that could use the GPUs a lot better. And what used to happen earlier was that you had to use the smallest size of an instance that you could use was a 32 vCPU instance, which, as we all know, are insanely expensive instance types. And if you just wanted to run some basic builds and stuff like that, it was just a very, very expensive way to get that one GPU available to you. Now, it makes it a lot easier to get one GPU attached to much smaller instances. And here it's 4 vCPUs now attached to one GPU. So I think that's about the right balance between your CPUs and your GPU. And it reduces the costs dramatically to try out one of these instances. So yeah, I think this will allow a lot more folks to start using CodeBuild for their workloads, especially as we are seeing tons of new training and compilation related activities coming up in the AWS workloads.
Do you know the instance type that this would be?
I think this might be a flavor of the Ps. The GPU instances have traditionally been the P types. So though in CodeBuild, I have to check. It's been a while since I've gone back to the CodeBuild console.
Well, I guess a P2.x large would be a 4 vCPU.
I think that is 32 vCPU. It might be offering less than that now.
Interesting. Okay.
Well, I think this is really, really nice and flexible for being able to have a workflow pipeline that can run some GPU code.
So maybe you're just testing out inference
or just making sure that your stack works.
And Correct. You don't need 32 vCPUs to do that.
Yeah. So I think so they have different compute types. They don't do the actual instance types. CodeBuild actually just does t-shirt sizes, small, medium, large. And they have ARM, Linux, and Windows small, medium, larges. And I think the GPU, they have a Linux GPU small compute type, which is build general 1 small. And that's what you would end up using.
Oh, I see. This is great. This is so how do we want to rate this one? What's our verdict on this one? I think I know where I'm leaning.
Go ahead. Why don't you take the call this time?
Well, this is obvious simplifies.
Yeah, I think more than simplifies, the fact that it reduces costs just makes the choices easier.
Yeah.
And you're no longer making a lot of the trade-offs that you were making earlier. So yes, simplifies and reduces costs. So I like it too. And this one, if you actually go to the documentation, the details are pretty clear, pretty straightforward. I'd give this a good 4.
All right, let's put the 4 clouds. No, I wish there was an example on the main page of just kind of a ballpark pricing of this is,
it could be a
50% reduction in cost or a 100% reduction in cost, whatever it is.
Yeah, I agree. Yeah, pricing isn't very, very obvious or clear here in the documentation. So I guess we'll have to go figure that out ourselves.
Well, this is really neat. Do you use CodeBuild?
I do use a lot of CodeBuild, especially for a lot of the old Java apps where compilation is kind of necessary. I'm not much of a front-end guy, but I can imagine CodeBuild being incredibly valuable when you have a lot of these NPM packages that have to be downloaded, packaged up, bundled up. CodeBuild could be incredibly valuable over there. Since most of my experience has been with backends, a lot of the Java, applications have typically found a lot of use in CodeBuild.
Cool. All right. Well, let's switch gears over to an S3 announcement. And this one's been making the rounds a little bit, so I'm really curious to hear your take on it. All right, here it comes.
All right. right. This is Mount Point for S3. Now, at first glance, you look at this and you say, okay, does this replace EBS at half the price? Right? Is that the idea? They're saying, okay, you can now mount an S3 drive, and when you paste an object or create an object into a directory that's actually an S3 bucket, it's going to, in the background, translate that into an S3 put or an S3 get to read it. So I can see that.
Is that the intended use case here?
I think it is intended for a lot of legacy applications that used to run on Hadoop or EMR, which did not really have the, like they would have to make a lot of code changes to actually move from a POSIX-based file store to something like S3, which is an object store.
So this is where getting even something like Boto or whatever is the equivalent in Java world, the Amazon libraries to then make native S3 calls. That's not going to be feasible, or don't want to touch the code because no one understands it anymore.
Yeah, and I think in this particular case, like if I were the product manager at AWS, I would actually not have created this service because it just causes so much more confusion amongst the customer base. I am pretty sure that over the next year, I'm going to see a whole bunch of people use this service in the wrong way, where they mount an S3 bucket, their applications start using them in read-only mode where it might work okay. And then there are going to be two consequences. Number one is someone will decide that, I can do a few write operations with this. And they'll start treating this like a file system and start writing a bunch of stuff. The other thing that's going to happen is that people are going to be doing crazy stuff like unzipping stuff onto this Mount Point, or just doing a whole lot of LSs or just reads and writes onto it, and they're going to get a super massive bill.
That's a good point. If you have a shell script, when you're writing a shell script, you can treat ls as an absolutely costless operation, and be very, you can even embed an ls command and some backticks and pipe it to something else, and whatever you want to do.
Yeah.
And you don't
think about it, that there's actually a cost associated with that.
Correct.
Or creating temporary files.
Correct. And the pricing for this service is based on the number of API calls that happen into S3. And that just means that it's ripe for, getting yourself a super massive AWS bill.
Well, I'm looking at their roadmap here. So you can see that, support for make dir. So what's that going to look like? What is the logical mapping? We need to define semantics of make dir. Is it local? Because in S3, you don't really have a directory, and you have these keys that have slashes in them to kind of give you the idea of a directory and to help the hashing algorithm. But it's not the same thing as a directory in a traditional file system sense.
Exactly.
So being able to now map all these different abstractions onto each other, you're right. This could be a bit confusing for people.
I am so sure that things are going to, cause so much confusion, and mostly people are going to be burnt by trying this out. Because even though it's targeted at a very small, very narrow niche, you're going to have a whole bunch of people who look at this and be like, I can totally apply this to my use case. And they are going to be in for a really difficult time.
Well, hopefully these, I can see exactly what you mean. I never want people to get burned on their cloud compute costs. So hopefully that doesn't happen. Yeah. But I can see what you mean, especially if you are just swapping one for the other without understanding the underlying abstraction layer. You'd want to keep an eye on your cloud costs more than once a month. You want to check in on that very regularly, especially for the first couple of weeks of usage, to make sure there's no surprises.
Correct. Like I think a much better solution, generically without causing confusion, would be to do an S3 sync into an EBS volume. An EBS or an EFS volume, depending on what you're trying to do with it. And then once you've performed all your POSIX operations, then sync it back into S3. But don't try to mix these two completely different types of file storages. It doesn't make sense. Your software that's designed, the tools and the clients that talk to your local file system make certain assumptions about what a POSIX system is supposed to do. And S3 Mount or Mount Point for S3 is not a POSIX compliant system. So you are bound to have something break as you're trying this out. I think you just went on mute, Stephen.
Sorry about that. I was just reading through the
technical blog post. I do really like that the technical blog post seems thorough. And they're talking about the implementation. They're talking about, I'm looking at this part, this caught my eye about using the automated reasoning. S3, engineers use S3 automated reasoning to mathematically define the behavior of key systems. Interesting. Okay, so this is talking about their implementation. I see, about file system semantics offered. So this is what you're highlighting, that it's actually a pretty complicated problem because the underlying models are somewhat different, right? Even things as simple as file permissions, right? What if you have a script which depends on something being executable or not? You'd want to know if that's actually the case.
Correct. I bet that, right now this is a fresh announcement, so we are actually diving into all of these details. 6 months down the line, someone who looks at the AWS product catalog is going to see Mount Point for S3 and will read the brief description that says, if you go back to the front page of that of the website for Mount Point for S3, it'll basically say mount your AWS it'll say something like, mount your AWS bucket onto a file system drive, and it'll have a lot of disclaimers and stuff in fine print, but no one's going to read that, and then they're going to Google for how do I mount an S3 file system, and it'll say Mount Point for S3, and that's the next thing that they'll mount, and they'll start using it, and then things will crash and burn. I can almost see that happening 6 months down the line. So I actually think it's a terrible idea. It just causes too much confusion, and I don't know if the benefits of this outweigh the confusion that's going to cause.
Yeah, well, here's hoping, right? And how long have they been working on this? So it's an alpha release now, but if we look at their commits, so this repository has been going for, let's see, scroll back a bit.
My guess is like over 6 to 8 months.
Wow, okay.
This is the public repository. They probably had it internally as a private repository for a while.
Yeah, okay. Well, at least their Git ignore is 6 months old. Okay.
Well,
yeah. It'll be interesting to see what are the use cases that evolve, but I think you're right. We'll find some usage among a niche, but it shouldn't be advertised as a general solution that makes EBS obsolete.
Yeah, it's not. It's definitely not. And I would give this a complexify alert.
All right.
What do you call it? Complexity alert?
Complexity. Let's put this complexity alert.
Yeah. Warning to anyone who uses this. Please be 100% sure about why and how you're using this service. There are a lot of gotchas. You have to read through the documentation, really understand the implementation details before you use it. And I still think you might have to make some code changes before you can deploy this.
Well, and I think keep an eye on your cloud spend. If you use this, keep an eye on, or maybe set up CloudTrail and look at your S3 API calls and get a before and after, so you can just even look at the frequency of your API calls. Like you said, if you have some LSs and creation of maybe thousands of temporary files that are each very tiny,
that's something you don't want to do in S3, is create
10,000 temporary files that are a few bytes each. And that's really easy to do in Bash.
Exactly. And that would be a terrible, terrible idea with this. Yeah.
All right. Well, what's your cloud rating? Now, I'm going to argue that they did have a lot of documentation. They have a roadmap. And in the recent CloudOps conference, the roadmap sessions were the most popular.
Okay. So I'm going to give it two different ratings.
Okay.
One is for the documentation.
Okay.
And for the blog post announcement itself, I think that I'd give a 4.
All right.
Because it's very comprehensive. The second rating that I'm going to give is for product management decisions around this. And I think I'd go down to a 2 or maybe a 1.
Oh. All right. Well, okay. So it was very well presented, but maybe not the best idea. So I guess time will tell to see.
I might be wrong. I might be completely wrong with this, and it might take off incredibly well, become one of the fastest growing services at AWS, but time will tell. Or AWS might actually have an amazing quarter next quarter as people try this out, get massive bills, huge revenue for AWS. That might be a win as well.
Oh, they are pretty good. If you say, "Hey, look, I didn't realize that this bill was going to explode," they are pretty good at issuing credits.
I agree. I was just joking about that here, but I have serious doubts about this one. Okay.
All right.
Shall we move on to the next one?
Yes, the next one. Let's see. Which is going to be metric math. Application autoscaling with metric math.
Great. Let's do this one.
Let's do a quick CloudFix announcement, and we'll go on to metric math.
Sounds good.
Is your AWS public cloud bill growing? While most solutions focus on visibility, CloudFix saves you 10 to 20% on your AWS bill by finding and implementing AWS recommended fixes that are 100% safe. There's zero downtime and zero degradation in performance. We've helped organizations save millions of dollars across tens of thousands of AWS instances. Interested in seeing how much money you can save? Visit cloudfix.com to schedule a free assessment and see your yearly savings.
All right, I am back. How's the audio? Are the audio levels better or worse?
No, they sound muffled.
Okay.
Yeah, it's better now.
Okay, let me try to fix this.
Way better.
Okay, there we go. That's better.
Much better.
Oh, yeah, I got this new shock mount here, and as I was moving the microphone around, that's when I broke the microphone. So should be back in action next week.
Awesome.
But if any of you content creators out there have suggestions on perhaps a different microphone, I'm all ears.
Take a look at the Shure MV7. I use it a lot while I'm traveling. So I have this one is a Shure SM7B that I'm currently using, and that's like always mounted onto this. But if I'm traveling, I actually use the Shure MV7, and that has proven to be really, really good too. It's just a simple USB connect. You don't need any of the other audio devices.
Sure. That's all right. I will have a look. Thanks. For this one, this is still a good mic. What I need to do is get in there and fix the switches. And what I want to do is measure this and then 3D print a stand for it so I can use it as a guest mic. I think its days as a boom mic might be over. But as a guest mic on a desk stand, I think it still has a chance at another life in it. So always good to reuse and to repurpose.
I agree.
All right.
This one is all about autoscaling groups.
Okay, application autoscaling now supports metric math for target tracking policies.
Yeah. So historically, the rules that you would set up for autoscaling were typically fairly simple, right? I mean, you would look at CPU load, you would look at or your memory utilization, whatever, and then decide when you need to scale up or scale down. But invariably, your decision may need to be a combination of certain metrics. Simple math, like the average of something, or the average of two different metrics, for example. You want it, or you want logical operators. Sometimes where you say either this happens or that happens. So logical operators were being supported in Autoscaling Groups, so you can kind of hack your way through it. But usually the other way to hack around your metrics was you would create a different CloudWatch metric, or you would create another metric which was a combination of other metrics, and somehow use that as a mechanism to decide on your autoscaling group. But now that these arithmetic operators are supported natively, I think it goes a long way in helping you create autoscaling policies. The reason why I particularly picked this one was to re-emphasize, more often than not, and I had a LinkedIn post about this, so check it out, where I have a few more details. More often than not, I find that a lot of developers will create decent auto scale up policies, but they don't put in as much time or effort in creating the scale down policies, believing that it's too complex. And yes, in a number of cases, those policies have a lot of decisions that have to go in before you can decide to scale something down. You don't want to inconvenience users or consumers as they are in their sessions and so on. So it does require more work to create the scale down policies because the risks are greater. And so a lot of developers avoid doing it, and they figure that, at some point of time, they'll just manually scale down as needed. But that almost never happens. And you end up spending a ton of money on these autoscaling groups, which are just constantly scaled up. So this, I think, helps in reducing the overheads involved in creating good scale down policies. And I hope that will help people save money on their autoscaling groups as well.
That's a really, really interesting point you made, that often people don't plan for the scale down part. And then we looked at, especially over the pandemic when many businesses had to scale down, and being able to understand how to do that quickly is really important, right? I guess it's a beautiful reflection of human optimism that we're always thinking about scaling up, but sometimes you have to scale the other way.
Correct.
And it's really good to be able to do that quickly and not have to scramble and do that haphazardly.
Correct. And the reason to do that effectively is this. Very rarely have I come across services that truly have peak loads 24/7. There are at least 4 to 6 hours a day in almost any service where your workloads are going to be a fraction of that peak workload. And so even if on a daily basis there is 4 to 6 hours where you could operate at 50% or even more, or 50% or less scale, that's tons of money that you could be saving and not wasting away.
Absolutely. It's we always, I've seen so many of these Medium posts where they write a blog and they go over provisioning this huge amount of infrastructure for a personal blog, which would have been fine on a light sale instance, right? At $5.
Or even just dump it as an S3 static site.
Yeah, that's even better, right? And it'll probably cost you 17 cents a month, right? I think all of us have, personal blogs. Well, ever since Google Reader bit the dust, personal blogs have gone the same way. So most people just don't have that much usage, unfortunately.
Correct.
But going back to the metric math, as I'm looking at this, my only worry is that some people will push this too far. So I'm thinking, you could, with these operators, you could do you could probably cobble together a little linear regression if you really wanted to. Now, is that a good idea, or is there a time where you want to then shift outwards to a more powerful tool? Like, how far do you want to push this? I mean, it's technically with plus and minus and divide and sum and average. You could even do a little neural network if you wanted to, but at that point, you're probably better off bringing it into something like Splunk or Datadog or any other tool, and then having a bit more fine-grained control. So where do you draw the line between how much complexity you're going to have with this?
So I think if you look at the autoscaling rules, they're pretty straightforward. You have a simple expression in there that decides whether you meet a certain threshold or not. And if it crosses a threshold, you basically scale up or scale down. And given that constraint, I'm not very concerned about someone like this is not a programming language where you write up all these crazy stuff. It's literally an expression you write, and that expression either is above a threshold or below a threshold. That's basically all it can do. So not too complicated is what I'd say.
So it's not, because anytime you have as programmers, right, say, "Ooh, math. Is this Turing complete? Can I get a windowing function in here?" And you always worry when there's an embedded language that grows in scope. So I'm glad that they've limited it to simple point in time. You don't have, you have average, but you can't look at, can you do time windowed operations and say, if I'm getting this many requests over the last 10 minutes or 10 seconds?
Yeah, so time window is a parameter. It's a separate field where you look at, you can say within the last 5 minutes, 10 minutes, whatever. The rules allow you to set that up separately. But the expression is just as simple as metric plus metric or metric minus metric kind of setup. And it either is greater than or less than a certain threshold.
Yeah, so you do something like maybe number of active shopping carts versus number of, failed credit card payments or something. And then you could scale up the payment processing backend.
Correct. Or you could do things like, if my API call latencies are above a certain threshold, then do this. Or you can say the combination of the latencies for service A and service B should not, like, I can see this happening in telco use cases where there definitely are scenarios where the sum of the latencies across all of your different services typically needs to be less than 200 milliseconds.
No, that makes a lot of sense.
Each individual one could be between 10 and 50 milliseconds, but the sum of them has to be less than 200 milliseconds. And when you start seeing your P90 for that, or rather P90 or P99, am I correct getting my numbers right?
Yeah.
If your P99 is lesser than that or is greater than 200 milliseconds.
So it's saying if in 1 out of 100 or less, it is less than a certain threshold, then you're okay. But if more than 1 out of 100 are crossing a certain threshold, then that's an unacceptably high error rate, and you need to do something about it.
Correct.
That makes a lot of sense. That's really neat to see.
So I like this. I'm really hoping that this will make it simpler for people to create good autoscaling groups or autoscaling groups to scale down in particular and save themselves tons of money. And it again simplifies the art, what used to be an art of creating autoscaling policies. It simplifies that a lot.
Now, when people are using these custom operators, what's the best practice in terms of documenting how these new operators are made, so that you remember how they're constructed when you're looking at your CloudWatch logs?
I think the metrics, you can typically just use metrics. So metrics are generally numerical figures or numerical numbers. And so these mathematical operators on them are fairly
So it's still transparent.
fairly straightforward.
Okay. Yeah. All right. Well, then how do we rate this?
I'd give this a 3.5. And the reason why I'm cutting half a point is it would have been good to see a couple of examples of, the operators being used.
Yeah, I agree. It would be neat to see an example.
Yeah, just a screenshot would have been great to show how someone used one of these operators.
And there is no accompanying blog post with more details.
There isn't one, yeah.
No. All right. It was interesting at the CloudOps conference last week, and I'm working on a full blog post about that. There's the amount of work going into CloudWatch and CloudTrail and all of the things that you can do with logging and monitoring and compliance. It's really exciting. And I'm saying exciting, it's by nature a somewhat dry subject, but all of the facilities that they're adding around it, it's really neat to see how much visibility you can have into your operation.
Yeah, I think it's come to a point where CloudWatch, even though it's a great, highly scalable logging service, for most practical reasons, most organizations struggle to use CloudWatch like a logging system. It either gets too expensive, you can't flush out logs as frequently as you would like, and between expense and this and the usability of CloudWatch doesn't even remotely compare to the likes of either Loki or Elasticsearch or any of those other tools that make it really simple to get to a log, search for it, get nice visualizations around your logs, any of that stuff. So I think CloudWatch has a bunch of work to do, but I'm confident that they are on it and they have enough precedent to go refine it and get it to a point where customers will start loving it.
Yeah, totally. They're definitely on the case.
Yeah. And what's going for CloudWatch in general is the fact that every AWS service has a naturally built-in integration into CloudWatch. So you get that free out of the box.
Absolutely. All right. Well, I will definitely work on that blog post, and we could probably go over it in the next, in either next week's episode or the one after that.
Sounds great.
All right. Well, I wanted to shift gears into a deep dive on compression using CloudFront and how to reduce your data egress costs using compression. So we're going to take a quick break for CloudFix, and then we'll come back and we're going to be talking about compression.
Public cloud costs going up and your AWS bill growing without the right cost controls? CloudFix saves you 10 to 20% on your AWS bill by focusing on AWS recommended fixes that are 100% safe with zero downtime and zero degradation in performance. The best part? With your approval, CloudFix finds and implements AWS fixes to help you run more efficiently. Visit cloudfix.com for a free savings assessment.
All right. And I'm putting the link to the blog post here so you follow along. So that is now in the chat. We called it Pressing Your Luck, How to Use Compression to Reduce CloudFront Costs by 65%. All right. I'm going to use the great special effects of the A10 Mini. And there we go. Great. All right. Here we are. Let's change the layout here. I will take that off.
Wait. We got to do something with the layouts where I am not on the screen. Give you a little more.
There we go. There we go. That's so perfect. I think that'll work really well. Okay. Amazon CloudFront compression. So, Rahul, I wonder if this is a familiar sight to many of our audience members. It is for me.
Old Windows.
Yes. And look at the transfer rate, 5.3 Ks per second, which is good.
Incredible. I used to be on a 2400 baud rate connection at one point of time. So.
We were at the same. We at one point we had a couple of computers shared over a 2400 baud using what was called RAS.
Nice.
So it used to take a long time to download things, and it still would take longer if it wasn't for some great things that are happening in the background, and one of those is compression. So let's talk about what compression is. So I like this quote: "There is no excuse for serving uncompressed HTML, and you can save 65% or more by enabling automatic compression via CloudFront." And so zooming out, if you don't know what CloudFront is what's called a CDN or Content Distribution Network. And the idea is you have your server, and that can be located in a particular region. But then, or if you have an S3 bucket, that's not tied to a particular region. But for lower latency, for higher performance, you can use a CDN, such as CloudFront, to distribute your content to the very edges of your network. So these are very low latency data centers that are located near major urban areas. And so with that, you also want it to be as fast as possible, and that's why you want to use compression. And why would you want to do it? Well, in addition to it being a better experience for your users, because they get a faster and more zippy experience, CloudFront bills you based on data egress. That's the total amount of data out. And they don't care whether it's compressed or not. And 88% of websites use compression. And so it's definitely considered a best practice. Now, in some of the compression discussions early on, people were wondering, well, doesn't that slow down things for the client? Because then they have to do all this extra work to compress it. Let's change our view. It's all right. I think we want cinema view.
I think we should get you on a solo layout here.
There we go. We do solo? Okay, there we go.
Yeah, there we go.
So one of the criticisms of compression was that it would take the client, it would be an extra burden on the client because then they would have to decode it. But doing studies, it turns out gzip compression is extremely efficient. And gzip decompression is extremely efficient. We're talking like 2 orders of magnitude versus transfer time. So it's not a concern unless you have an extremely low-powered client, like an IoT device. But in 99.99% of use cases, the benefits of compressed data outweigh the tiny little extra burden on the client of decompressing. So how does it work? Well, when you're on your computer, you make a request to a server called the origin. And so that's your EC2 instance, that's your S3 bucket, and the origin gives you a response. And so this is how it works without compression. It's just a very simple, I want index.html and framework.js, and the server hands it back to you, and the browser then gets that response and renders it. So that's how it normally works. Now here's how it can work with CloudFront. So over here, this is the client. They're going to ask for the files that it needs. So index.html, it needs the JavaScript framework. And see this here, these headers. One of them is called accept encoding. So accept encoding means, hey, if you send me something compressed, I can uncompress it. And then CloudFront, so this request is going to go to CloudFront first. And CloudFront is going to see, do I have that or not? If CloudFront doesn't have it, it's going to then ask the origin for it. Now the origin doesn't need to have it in a compressed state. It can have it totally uncompressed. And so in this example, the origin has, say, a JavaScript framework, an XML file, and your index.html. Now your response from the origin to CloudFront is going to say, oh, look, I have these files, but they're not compressed. CloudFront's going to say, wait a minute, I'll store a copy of these files so the next time this request comes in, I don't have to ask the origin again. And CloudFront will also, if you enable compression, it will say, I'll store a compressed copy of these files so that whenever there is an origin or whenever there's a client that can support compression, CloudFront can give them the compressed copy instead. And the great part about compression is that it works really well on text. So things like XML and HTML and JavaScript, they compress really well. If you've ever opened up an XML file and had a look at it, there's a lot of extra tags and there's usually a lot of redundancy in XML files especially. And so that they lend themselves really well to compression. And so you see finally CloudFront responds back with the file that the client requested, and it has this content encoding header, which is saying, hey, look, this is compressed in gzip. And then the client knows to decompress that. So this is what we call a cache miss in CloudFront looks like. So it's saying, again, the client made a request, CloudFront didn't have it, so it asked the origin for it. The origin returned it in an uncompressed form. CloudFront compressed it and sent it back to the client, and kept a copy for itself so it can return either compressed or uncompressed the next time. So now here's the next time. So the client makes the request. CloudFront says, oh, look, I've got a compressed and an uncompressed copy of all those things. The client, because the accept encoding header says, I can support decompressing if you send me a compressed one. So CloudFront will pick the compressed one to send back. And this will be much faster. And it's faster because you don't have that extra latency of going from CloudFront to the origin. And it's also faster because it's sending a compressed file that it didn't need to spend time compressing because it did that last time. So that's the basics of how compression works. Now, how do you enable this in CloudFront? Well, you could go to the CloudFront console and you can click on this button that says compress objects automatically. Yes. Now, there are certain parameters if you dig into the details of this. There's one called enable accept encoding gzip and enable accept encoding broadly. And so those are just two compression codecs those are the two standard ones. Gzip's a bit older, broadly's a bit newer. They're supported on the vast majority of web browsers. And also you want to have a TTL greater than 0. And so that means how long can CloudFront trust that this content isn't going to be updated? Because if it was something like late breaking news, you wouldn't want the cache to be too long because the origin could be able to change that. Okay, how do you enable it via the API? You first need to make this file called a cache policy. And this is a JSON document. And the key thing is what we said, we want to have a TTL value, that's time to live. So that way we know CloudFront knows how long to hang on to that content before requesting a new copy from the origin. This is showing that it's going to support broadly and gzip encoding. And it's also looking at that accept encoding header. So this is how you want to start. So you have to create this cache policy document. The next thing you want to do is create the actual cache policy from that document. Now, in order to do that, you use this AWS, you can use the AWS CLI, and you use AWS, and then you use CloudFront, so that's the service, create cache policy, that's your command, and then you point it at this file, the one that was just back here. So point it at this file. And so that creates a cache policy. Now, once you have a cache policy, you want to associate that with a CloudFront distribution. And so the way to do that is you run the CloudFront update distribution command here. And this is your distribution ID. And then this is the distribution config cache behaviors. So there's another file you have to worry about. And then you also have to match what's called the E tag. So the E tag, you actually can query you have to query the cache policy and the CloudFront distribution to get its E tag. The full details are available in the blog post. So we put the link in the description. So it's a little bit involved. You'd want to make sure that this is always enabled for all the CloudFront distributions, unless you have a really good reason to disable compression. Now, one note, and this is a real source of confusion, you may hear when you read about compression that, oh, it's not good to compress binary files. That's a bad idea. And you're right, because binary files like images and videos, they have compression already built into the file specification. And so when you compress a JPEG or if you compress an MP4, you're actually just adding more work without any extra benefit. And you notice that in the worst cases, you can compress a video and the file actually gets bigger. And so there was a lot of confusion over if people had to work around this. But a really good thing about how this compression works is CloudFront is smart about that. It's going to look at the file types and it's only going to compress text-based format. It's not going to try and compress PNGs or JPEGs. And you can actually get the full list that CloudFront supports. Let me see if I can pull up that list here on the blog post. Here we go. File types.
Should I pull that up on the screen?
Oh, yeah. Here, I'll put this on the screen there. Add to stream. Yep, serving compressed files. So there's a list here that are all the files that CloudFront is going to compress for you. And you see that they're all text files. So you don't really need to worry about this whole, if you see a lot of chatter online about, oh, don't compress binary, don't worry about it. CloudFront is not going to try and do that for you. So the easiest way to do this is just use ARIA CloudFix. And so CloudFix, it scans all of your CloudFront distributions, and it can enable compression if there's no caching or compression policies in place already. So the automation is going to check, is there no compression policy already, because they don't want to override an existing setting that was made manually, or there's no policy that doesn't expressly forbid compression. So if one of those two things are true, then it's going to enable gzip and Brotli compression for you. And that it's kind of a strict win. Your users get a better experience because it's a faster load time and lower latency, and you get a lower bill. So that's one of the ways that ARIA CloudFix gives you nonstop AWS cost savings. So go check that out. Check out the blog post. The link, we put that in the comments. And it's really exciting. It's definitely something you should be doing, but it's easy to overlook, especially if you're making lots of CloudFront distributions. All right, Rahul, let's bring you back on.
Great. Thanks for that deep dive and that great explanation around compression for CloudFront.
Yeah, it's my pleasure. It was really fun using the on-screen effects there. I really enjoy that.
Yeah. No, we still have to get our coordination in order. But again, this is a live stream, and we hope to, react to whatever happens, whether it be your questions or situations that we land up in. That said, do we have anything else to cover today, Steve?
No, I think that's everything. We're looking forward to another busy week of content creation. What do you have coming up for the week?
I am preparing we are currently in prep and recording mode for the AWS Insiders podcast, and I'm really excited about the new season. The new season should ship early April, I think, if I'm not mistaken. But we've already started recording, and there's been tons of exciting new content over there. Apart from that, there's a lot of stuff coming down the AWS pipeline that I am literally just trying to keep my head above the water with. And we'll be bringing more of that stuff to you over the next few weeks. Other than that, summer is going to be a crazy amount of travel with all the different conferences from the AWS summits, where I'll be visiting all of you, as well as FinOps X, which is in San Diego at the end of May. At the end of May, correct. So it's going to be a very exciting summer.
Absolutely. There's FinOps X, the AWS regional summits. And then before you know it, we're going to be prepping for reInvent.
Time really does fly. It just feels like reInvent just happened, and we are still kind of catching up on all the announcements that were just made.
Absolutely.
But yeah, that's the whole point of reInvent.
I've got 32 pages of notes from the CloudOps summit last week, so I'll be going through those, working on blogging about those. Got some exciting new other blog posts coming out with the working on elastic IP addresses, all different cost optimizations, finders and fixers with ARIA CloudFix. I'm looking forward to sharing more of those with you, doing more deep dives, keeping the content going to help keep your costs under control.
Awesome. Thanks, everyone. We'll see you all very soon.
Sounds great. Thanks again. Talk to you later.
Is your AWS public cloud bill growing? While most solutions focus on visibility, CloudFix saves you 10 to 20% on your AWS bill by finding and implementing AWS recommended fixes that are 100% safe. There's zero downtime and zero degradation in performance. We've helped organizations save millions of dollars across tens of thousands of AWS instances. Interested in seeing how much money you can save? Visit cloudfix.com to schedule a free assessment and see your yearly savings.